Welcome back. All right, let's jump back into this and talk a little bit about displaying some formatted output with what's known as F strings. An F string is a special type of string literal that is prefixed with the letter F. So here we are using our print. Here is our little F. As you can see, it's in the parentheses, but before the first quote. And in this case, because we haven't done anything special, it essentially ignores that F. But what this F is doing is it's telling the print statement that we want to format this parameter. With the F string support, we can support placeholders for variables. So name equals Johnny. So we're assigning Johnny to the name variable. We're saying printf, here's our single quote, hello, and then the curly bracket with the name of our variable inside. Close the curly bracket, single quote in parentheses, and it's going to take whatever's stored in our variable and substitute it in our statement. We can have placeholders that also are expressions that are evaluated. So again, here's our F statement, single quote starts there. Our curly brackets say take 10 and do it plus 2, and then instead of outputting that as part of the statement, it actually does the math and says my value is 12. Here we have val equals 10, so 10 is being stored to my variable, and you can see in the curly braces, we've got val, which is our variable here, but we're doing another addition of 2, so the result is 12. We can use some special ways of formatting, and we've got format specifiers that can help with the placeholder. To do this, we use the colon. Everything left of the colon is going to be the variable. Everything right of the colon is going to be our formatting text. The dot means that if it's a floating number, we want to put the dot and then allow it for 2 additional characters after the dot or the decimal, and that the value should be float. So that's what that stands for. Let's break that down again one more time. Colon, everything to the left is the variable name. Everything to the right is how to format it. The dot 2 says put the decimal point where it needs to be, and then give us 2 more characters and stop. It will round that last character based on the third character. And F says output this as a float. This is exactly what this is saying. Round the value to 2 decimal places and display the value as a floating point integer. Here's another example of that. So we're assigning this number to our num. And we're outputting the number. Everything to the left of the colon is the variable. This time we're specifying the thousandths mark, which is the comma. Then the 2F says output 2 decimals and make it a floating number. So here it's adding the 1,000 marks because we told it to, and the decimal with 2 spots, which we already had anyways, but this continues it through. In this, we're assigning discount, or assigning 0.5 in discount. Everything to the left is the variable name, and we want to do dot 0, so we're not going to display any decimals. And then we put the parentheses there, and that tells the printf statement to convert this number to a percentage. So 0.5 is actually 50%. And here you go. In this example, 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything to the left. This this comma means put the comma in the thousand marks. And D stands for decimal. So automatically convert this number to a decimal, which it already is. 1, 2, 3 with the 1,000 mark, 4, 5, 6, 1,000 mark, 7, 8, 9. Now we can do 1, 2, 3, 4, 5, dot 6, 7, 8, 9, and store it in num. Everything to the left is the variable. Dot 2 means give it two decimal points. And E is scientific notation, so convert this number to scientific notation, which happens to be 1.23 E with 4 decimals. So it means to move this decimal over 4 places to get the row number. We can specify a minimum field value So the width of this field, we have this number, and we're saying the number is everything to the left is the variable. If there is a number that is before the dot or before, in this case, because we want the 1,000 marks, it's going to be what the field width is. So in this case, it's 12. Plus, we want the 0.2 in the float. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So as you can see, it puts the number in 1, 2, 3, 4, 5, 6, 7, 8, 9. And it does count because we told it to do the 1,000 mark, plus we said keep the decimal with 2 characters. It counts the decimal and the comma as part of the field width. We can use this symbol for left alignment, right alignment, and then the caret for center alignment. So in this case, this number is going to have a field size of 20, and whatever is in number is going to be left justified. Oh, if I spell that right. It's going to be 20 feet. The number of field characters is 20. So anything that is left over or blank is going to be out the right side of the field. This does just the opposite. So this is right alignment. So you're going to, let's say number is 10 characters wide. You'd have 10 spaces. And then whatever my var is, or excuse me, in this case it's num. That's 10 characters. And then finally, center does just like these two, but it's going to evenly put spaces out the front and the back, and then say my var. Here's the order for designators in a format specifier. First, we always do the alignment. Then we do how wide the field should be, whether there should be a 1,000 marker or not, our precision, and then the type. Example. Number colon, everything to the left is the var. This is the alignment. This is the width. This is the 1,000 marker. This 0.2 is the precision, and F is the type. Just so you know, a magic number is an unexplained numeric value that appears in a program's code. So like this, we have this balance times 0.069 is the amount. Well, what is this number? Let's say I come back later and I'm reading this code, Why 0.069? Is it an interest rate? Is it a fee? What is it? We don't know because it's just a number that makes no sense. There's no variable naming it, no nothing. We don't have any code comment telling us what it is. So it's this magic number, and this can be a real problem in code later on. Um, so we try to avoid magic numbers. As we said, it can be too difficult to determine the purpose of the number. If the magic number is used in multiple places in the program, it can take a lot of effort to change the number in each location. So one example is 3.14. We know that more than likely that's probably pi. But if we have it throughout our program and some point we need to change it, we have to make sure we find all these 3.14s and change it to whatever number we need it to be. We can mess that up. It can be time consuming. And so, again, we don't like magic numbers for that reason. You take the risk of making a mistake each time you type the magic number in the program's code. For example, suppose you intended to type 0.069, but you accidentally type 0.0069. Now you've made a mistake, and that error is going to be hard to find. So the way around magic numbers is name constants. A name constant is a name that represents a value that does not change through the program's execution. Please note, when you are creating a name constant, the proper way to name the variable is all uppercase and spaces are underscores. So in this case, we're saying 0.069 is an interest rate. So now this statement means a lot more. We're taking the balance and we are multiplying it by an interest rate. The advantage of using name constants is that a name constant makes the code much more explanatory, self-documenting. Name constants make code easier to maintain. You only have to change it in one place, and wherever you used that constant is now changed everywhere. Name constants help prevent typographical errors that are common when using magic numbers. Essentially, because you've typed it once, you don't have to keep typing it over and over and over again. You don't have to worry about accidentally typing in the wrong number. If you type in the wrong name, your code won't compile. So, won't be interpreted. You'll get a syntax error, and at least you can make that change pretty quickly. So that is the end of chapter 2. Like I said, we don't cover the turtle graphics, so we're not going to go over that in this video. If you want to go over that in your own time, feel free to do so, but we just don't do it. And so this concludes chapter 2. I hope you got everything. If you have any questions or concerns, please make sure to email me, and I will answer those questions as soon as possible. I'll see you next time for the next chapter. Have a good one.